And I think with that first integral, I think what you see in green here is what you see in green here, which has an alternative name of 1/4. Something respecting u. And I think what I have on the inside is a 1/red beast, which is an absolute piece of cake to anti-differentiate. Do you guys agree? And so I think in the end, I'm really left with a 1/4 natural log, excuse me. So 2x squared plus 3x plus 2. I can't hear you.
Absolute value.
Say it one more time?
Well, no, it's just parentheses because it's positive.
It's always positive. I don't need it.
You can put it down.
I can put it there. Oh no, I messed up. I forgot the other integral in black. I'll put it in. Plus 1/4 times something. I don't know, you guys. Which one of these three do you think I should use? Oh, I've erased them.
You can just differentiate that.
I know, but I want to anti-differentiate.
Or, I mean, you can just anti-differentiate that.
Yeah.
By, can't you just make it 2x to the negative 2 plus 3? Oh, I'm doing that upside down. Never
Yes.
mind.
I can't go there. Do you think this would be a trig sub?
There's a perfect square if you can add something.
Ah, but can't I always create a perfect binomial square out of a trinomial? Math D skills I'd probably use the complete square method. So let's do it. I think I got 1/, let's concentrate on the first two terms involved in the variable x, slough off in the plus 2. And with the first two terms, I cannot complete the square unless the leading coefficient is 1. So if you don't mind, I'll pull out a factor 2. Now to complete the square on x, I'm going to add to those two terms in black, within the black set of parentheses, the square of half the coefficient of x. So help me with this. The coefficient of x is 3/2. Half of that is 3/4. Square of that is 9/16. So that's what I'm going to add with my purple pen inside the black set of parentheses. It's not legal. I better compensate by, on the outside, adding a negative.
9/16.
I can't hear you. I can't hear you. 9/8. Because when I distribute the 2 in, that's what I really effectively added. Are you guys there? If you are there, I guess that leaves me with nothing more than the positive 1/4 times the integral of 1/, 2 times, look at this, a perfect binomial square. Paying the consequence, arithmetically speaking, for my actions, does that give me a 7/8, I think?
There's 3/16. 3/4.
It's because I can't multiply. Thank you. What I squared again generate my 9/16 is indeed a 3/4, not a 3/16. Please watch my arithmetic. Or how about saying this? This leaves me with a 1/4 natural log of stuff. I can't read it. Plus my 1/8 times the integral of 1/. Is that an x plus 3/4 squared? Is that a plus 7/16? Now that screams out at me that I'm going to commit to a tangent substitution. And so let's come in and allow
X to
X
be a tangent to
3/8.
X plus 3/4 as the tangent.
I don't know what's going on.
over. Independent variable. Are you guys okay with that? It's just a quick and easy tangent substitution. And that being the case, if you think I'm running amok, if you don't think this is going to help, then let's commit to the substitution. See if I get an integrand that looks beautiful. I get a 1/4 natural log of stuff. Plus my 1/8 times the integral of 1/. Okay, I'll slow down. I think that leaves me with a 7/16 times tangent squared of theta plus 1. Excuse me, I said plus 1, I meant, my goodness, 7/16. However, paying the consequence of my actions, I do think I need to find out what dx is in terms of d theta. But jeepers, that's just going to be root 7 over 4 times secant squared of theta, d theta. And so I guess I'm missing a factor of root 7 over 4 secant squared of theta d theta. If I'm not getting too sloppy, everybody, I'm sorry. But I think that leaves me with a 1/4. Natural log of stuff. Plus 1/8 times, I'll slow down now. You guys check this out. I can pull out a 7/16 out of these two terms as a common factor. But it cancels with root 7 over 4. Leaves me with a root 7 over 4 downstairs. But it's downstairs, so I'll invert and multiply. But that leaves me with the integral of secant squared over
Tangent squared
plus 1. But that's secant squared over secant squared. Oh, that's easy. That just gives me 1/4. Natural log of positive stuff.
Wait, don't you need to pull out a 7/16?
Well, the root 7 over 4 cancels out with this root 7 over 4 twice.
Oh, okay.
And the root 7 over 4 I did pull out downstairs, but I had to invert and multiply since it was downstairs. And I think that gives me a 1 over 2 root 7 times theta. But jeepers, theta is nothing more than the inverse tangent. You guys really don't want to play. Of this over this. Anybody?
X just equals.
So, anybody?
X plus 34.
I was hoping you'd say 4x plus 3 over
7.
root 7.
Square root 7.
Man, you guys know how to go silent.
I don't think this is complicated enough. Let's just go a little more.
Good, I can do that.
Yes.
Sir.
Where's the root 7 over 9 from the top of the hands first?
Sir, I'm sorry. I'm just being sloppy again. That's really root 7 over 4
Okay, where's that root 7?
from here. I think when it comes to, can I hide my fingers over this? Kind of just pretend it's a w squared. Well, I think when it comes to a w squared plus a squared, my trig stuff should be w equals a times tangent theta. But if a squared is 7/16, then a is root 7 over 4. That's really where it came from. From my traditional u sub, I call it w in this case. Yes? Oh, there's nothing that says I have to do that. I didn't have to do it at all. I could have just dialed it into using a trig sub. I just think it looks like a mess. After all, I get multiple terms upstairs. I just didn't want to deal with it. I just thought my life was so much easier if I can commit to a u sub, get rid of the x upstairs, and look at that, I did. Now with my trig sub that I haven't started yet, I've got a nice clean constant upstairs. I cheated in a sophisticated fashion and simply forced a u sub to exist with my Christmas colors. That's all I did. Come on, you guys attack me. Anybody else? Yes, sir.
So when do we know to include, I'm confused about the constant x plus 3/4.
Here's one. If you can close your eyes and then open them again and say, well, replacing this binomial with a w, does that look like my standard form for committing to a trig substitution? Like an x squared plus a squared, or x squared minus a squared, or a squared minus x squared. I think it does. And that's why instead of letting x be equal to something, I let the whole darn thing equal it. And if you really don't like what I'm doing, don't listen to me. Do this instead. Before you commit to a trig sub, make a simple w sub. W equals x plus 3/4. Then it looks like a clean w squared plus 7 over 16. Then commit to a trig sub. It's just include the next step. If you think that'll help keep things straight, go for it. You'll come with the same answer. David.
Going back to step number 2, when you have a rational expression, like, oh no, I'm sorry, step number 2 in example 5, just what you have on the board there. So the green and the
My
red.
apologies, yeah.
It's okay. So when you look at that, you have a rational function. You look at the denominator and you visualize the derivative of that, which will give you 4x
Plus 3.
plus 3. And then you manipulate the top to give you that derivative,
To be a factor of 4x plus 3.
factor.
Because of the leading coefficient of 1, however, I just knew with a 4x plus 3, notice in the coefficient of x to the constant, I'm multiplying by 3/4. So I made sure that with this coefficient of the constant, I multiplied by 3/4. That's where I got my green 3/4.
So you just factor out whatever coefficient you would need
For the derivative of what's downstairs.
and then you would do your u sub giving you that 1/4 in the second integral.
Yeah, but I gotta confess, this gentleman, I think, you told me at the beginning, factor this beast. And I have to confess, if this thing downstairs factors really nicely, I would not apply this approach. For those of you who've seen this before, and I assume you have not, those of you have, is this denominator factors nicely, I think committing to partial fraction decomposition, whatever that is, would be so much nicer, so much easier. Whatever that is. You'll know tomorrow. But since it didn't factor, I have no choice. Yes, sir.
Negative square plus 1 equals secant squared.
Yes. Sir, I know I skipped a step, but I said out loud, pull these coefficients out, ignore them. I already took care of it. That really is a tangent squared plus 1. Which is secant squared, and check out how lucky I got. Secant squared is canceled. Anybody else? Alright. Go home and cry. No, go home and get some fun practice with these, like in section 7.4. Excuse me, 3. You don't want to cry. So section 7.3. Let's take a peek at the following.